Question 7, we have to solve for 0 less than or equal to x less than or equal to 2 pi. In other words, we're solving between 0 and 360 degrees. Just looking at a fairly simple one first. Question 7g, cos x plus 1 equals 0. Well, cos of x is negative 1. If you're ever being asked cos of x is 1, cos of x is 0, cos of x is negative 1. So for 0, negative 1, 1, you sketch the curve for cos or sine. So I'm going to draw a cos curve here. Isn't that what the cos curve looks like? That's the cos curve. You should know the shape of your cos curve and your sine curve. So where does cos of x equal negative 1? Down there. Well, this is 360, which is now 2 pi. This is halfway through the curve, which is pi. So what's my solution? X is pi. Okay? So x is pi. But with the next question that we're going to do, you can't do it like that. So question H, root 2 sine x plus 1 is 0. Now, actually, let's just go back to that first one. What's if my equation, I'll just do another one over here. What's if my equation was cos x is 0? How do I solve that, if it was? If my question was cos x is 0, do you know, can you see the answers from that graph? What is it? Well, that's 0, pi, 2 pi. Yeah, it's basically that's 1 pi, 2 pi. It's at half pi and 1.5 pi. So half pi is pi on 2. 1.5 pi is 3 pi on 2. So girls, it's as simple as knowing how to convert a mixed numeral to an improper fraction. 1.5 is 3 on 2, so 3 pi on 2. And similarly, if you were asked cos x is 1, if you were asked here cos x is 1, what would your solutions be? Because there are actually two answers.
0 and 2 pi.
Yeah, 0 and 2 pi, all right? So please, for sine, cos, please use your sketch of your cos curve or your sine curve. Next one. All right, you got that down? So that was 0 and 2 pi, even though it doesn't look like it. Okay, question 7H. All right, what do I do? How do I do this? That's right. Root 2 sine x is negative 1. So sine x is negative 1 on root 2. Now, you never put the negative into your calculator. What does the negative tell you? All right, quadrants. There are 3 steps. You have to know which quadrants you're in. So in quadrants, which ones? Negative. So basically sine is negative. Sine is negative in quadrant 3 and 4. Then you'll need to know your acute angle x. So ignoring the negative, that only tells me the quadrants. Sine of what is 1 on root 2? You can tell me in degrees first. Sine of 45. What's that? Pi on, yeah, it's pi on 4. So acute angle x is pi on 4. It's 45 degrees. You think to yourself, 45 degrees, yep, that's 180 divided by 4. So it's pi on 4. Now, I know that I'm in quadrants 3 and 4. You can just put your little quadrants 3 and 4. Put your pi on 4 here. Remember the little butterfly? It means if the acute angle is pi on 4, it's the acute angle in quadrants 3 and 4 is pi on 4. So I've sketched it. Instead of writing 45 in here, I've put pi on 4. Now, this is 0. This is pi. You know, it's 0, 90, 180, 270, 360. This is 0, pi on 2 pi, 3 pi on 2, 2 pi. So how do I name this first angle? What's my solution? How big's that? Isn't it pi and another pi on 4? Or you know quadrant 3 as pi plus theta. 180 plus theta? Or if you don't want to, I mean, you should know the rule, but you can see that it's pi and another pi on 4. So therefore x is pi plus pi on 4. How do we do quadrant 4? Remember, it's that other angle. Yeah, it's normally 360 minus, so we go 2 pi minus the pi on 4. Now, please don't do these in degrees and then convert, because all I'm doing here is 1 and a quarter. 1 pi plus a quarter pi. Look at the coefficients of the pi. Pretend it's x plus a quarter x. It's 1 pi plus a quarter pi is 1 and a quarter pi. What's 1 and a quarter as an improper fraction? 5 on 4. So it's 5 on 4 pi. And what's 2 minus a quarter? 1 3/4. Do you get it? It's 1 3/4, which is 7 pi on 4. Okay? Now, I want to do some questions using the domain from negative 180 to 180 or negative pi to pi. So this question, these two questions so far are from 0 to 2 pi. We will just do question I first, which is, actually, or you know what we can do here? Let's give these, oh no, we won't. Yeah, all right, we will. Can you now just give me those answers? These answers are for x lying between 0 and 2 pi, right? Can you tell me what the answers here would be? So if I change my domain, so now if my domain is from minus pi less than or equal to x less than or equal to pi, same question, what would my answers be? So so you'll often see questions, solve this equation for this domain. So what we want, if you're going from negative pi through to pi, you've got to pass through 0. So we're still doing a whole circle, just watching, but you have to go from 0 to pi and stop. Any solutions in there? There aren't. And then from 0 to negative pi and stop. So this is 0, negative pi. Now I know I'm in quadrants 3 and 4. So if I ask you for the same question, give me the answers. 0 to pi, there are no solutions. I need these two solutions now, and they have to be negative angles, because I'm not allowed to go further than pi. Do you get it? So that's pi going this way, 0 to negative pi. So what are my solutions, girls? Good. So therefore x is negative pi on 4 and? Well, if that's pi on 4, tell me what this is. It's 3/4 of the way around. But I can go negative pi plus pi on 4. Look. All right, negative pi on 4 definitely. If you've got pi on 4 here, which is a quarter pi, haven't you got 3/4 pi there? Because 3/4 and a quarter makes 1 whole pi. So negative 3 pi on 4. Now, if you want to write that negative 3 pi on 4 out another way, it's actually negative pi. Look, negative pi plus pi on 4. Can you see how I got it? So that was really negative pi coming back in the other direction for plus pi on 4 is negative 3 pi on 4. Okay, what we're going to do here, just for practice, we're going to give answers for 0 less than or equal to x less than or equal to 2 pi, and then I'm going to ask you to give answers from negative pi to positive pi as well. All right, cot x is 1. So this is 1 over tan x is 1. Now what does this become? Tan x is 1, good. Which quadrants? Tan x is 1, indicating tan x is positive 1. So tan is positive in quadrants, all stations to central, quadrants 1 and 3. Good. So what's our acute angle? Yeah, acute angle x, we know it's 45 degrees, which is pi and 4. But I don't want you to mention degrees anymore. So quadrants 1 and 3, it's really good to do a sketch, girls. Really good, because it really eliminates errors. Okay, and it really makes it easy when you're doing your positive angles and your negative angles. You can see it. It makes it so much easier. So let's give our solution. So let's give our solution for x lying between 0 and 2 pi. So for x lying between 0 and 2 pi, what are my solutions? X is pi on 4 and? Yeah, it's 1 pi and another quarter. Can you see it? 5 pi and 4. Do I need to write it pi plus pi and 4? So it's 5 pi and 4. But if the domain that I ask you for the question is between negative pi and positive pi, so you've got to go from here to there and stop, and then do your other solutions from there to there. Got it? So what are these two solutions? X is pi on 4 and stop and go back. Yeah, that's your other solution. Okay, first one, second one. Negative 3/4 pi. Are we okay? All right. So girls, this is question 15 from exercise 3A. It says copy and complete this table and giving values to 3 decimal places. Haven't really left much room for it. So look, it's not, X is not given in degrees, it's given in radians. If there are no degree symbols, it's radians. So you must set your calculator to radians mode, RAD. Now, sine of 1, what is that? What's sine of 1? Radians mode.
0.841.
Yeah, just think what 1 is. You know, pi. See, these are all in terms of pi. Pi is 3.14. 1.5 should roughly be what sine, like roughly sine 90. Close to 1. What's 1.5?
0.997.
Yeah, see how it's... Do you get what I'm doing? What I'm saying? Look, girls, pi is 3.14. That's radians. What's pi on 2? Isn't that 90 degrees? That's 1.57. Yes, I know that's not 1.57, but that might be sine of 89 degrees or 88 degrees. Now, if I draw the sine curve, that's sine 90, sine 180, sine 270, sine 360. That sine pi on 2 is approximately 1. Pi on 2 is 1.57. You're doing 1.5, right? So we're expecting that this answer is just under 1, and someone just called out 0.997. Sine of 1 would be less than a quarter of 3. It's going to be, I don't know, somewhere, I don't know, what is it, 0.5, 0.4? What? Oh, is it 0.841? And sine of 2, negative? Yes, it is. Yes. What is it?
0.909.
0.909. All right. Who remembers Simpson's rule? Simpson's rule uses... No, Simpson's rule uses 1, 2, 3s and 4s, except in this case. So, normally Simpson's rule is area is approximately equal to h over 3. And then we have the multiplier pattern of 1, 4, 2, 4, etc. Right? So h over 3, whereas trapezoidal is h on 2. Right? So we then go times 1, 4, but we can't do 1, 4, 2, 4. There aren't enough numbers. So you just go 1, 4, 1. So it's h on 3 and then the multiplier pattern. I'm going to go times 1, whatever. I'm just putting the multiplier pattern in there. What's your h, girl?
0.5.
Yeah, it's the difference between the x values. So it's 0.5 over 3, one of these, one of those, and 4 of the middle. So it's 0.841 plus 4 times 0.997 plus 1 times 0.909. And that's Simpson's rule. But if I had more values there, I'll do one with 5 values in a sec. Yes, it's because beginning and end must be 1. All right, now if you look at your formula sheet, this is the one they give you. They don't give you the 1, 4, 2, 4. They don't, do they give? No, they don't give you 2 odds, 4 evens. I can't even remember which way it is, so I don't learn it. I just learn the pattern. But what we're going to do, get an answer to that. Let's see what we get. What do you get? 3, 3, 3, etc. Okay, so they just want it to 1 decimal place. So it's approximately 0. Well, go 1 decimal place. What do you get? What do you get? 1.0. So what they were actually asking you to do was use Simpson's rule to find the integral of sine of x dx between the values of 2 and 1. See how they've done between 2 and 1 and they've just got 1 value in between? It's not that accurate because they're only taking 3 function values, all right? But we actually can make it more accurate, and we're going to do it again. So that is approximately equal to 1.0 to 1 decimal place. Remember, Simpson's rule is an approximation of area. We're going to do the same question. I want you to do the same question with 1, 1.25, 1.5, 1.75 and 2, We've already got 3 of the values written down. We don't have to. Yeah, I'm moving up. I know, I'm moving. So I want the same question using 5 function values, 1, 2, 3, 4, 5. We already know what sine of x is for 1, 1.5, and 2. Can you work out those other values? And then we're going to work out the area again. Again, same formula, h on 3, with the new multiplier pattern. Who's got missing values for me?
0.949.
Is that the first one?
For 1.25.
Yep. 0.
0.98984.
All right, so the new multiplier pattern is, same multiplier pattern. Again, Simpson's rule uses 1, 2, 3, 4. It's h on 3. So what's your new h? What's your new h? Yeah, your new h is 0.25. So it's h on 3, which is 0.25 on 3. And the multiplier pattern, just put it under the table. 1, 4, what's next? 2, 4, 1. So Simpson's rule uses 1, 2, 3s and 4s. Multiplier pattern, 1, 4, 2, 4, 1. The only exception is if there were only 3 values, you have to go 1, 4, 1. You must end with 1s. It's symmetrical. Reads the same forward as backwards, meaning you must have an odd number of function values. Okay? Whereas trapezoidal rule doesn't matter. You can have odd or even numbers of function values.
So if you had 7, would it be 1,
2.
2, 3?
No 3s. So if there was 7, I'll write out the pattern for 7 in a sec. So here, what I like to do, I go 0.841 plus 0.909, they're single, plus 4 lots of 0.949 plus 0.984. Do you see that? So you do the 4 times together, plus 2 lots of 0.997. Now, you're going to need, unless you're really good with your calculator and using double brackets, I'd be doing all this bit first, press equals, and then times it by 0.25 over 3. Otherwise, you're going to have a calculator glitch if you don't. Actually, I don't need a bracket there. I can go plus 2 times 0.997 and put a single bracket. You know what you do. You probably don't even, I suppose you should write it out. But see, you write your multiplier pattern under the table. I'll just write down the 7 value one. It's 1, 4, 2, 4, 2, 4, 1. That's 7 values. It's always h on 3, and then, do you get it? So in the middle, the multiplier pattern's only ever 1, 4, 2, 4, etc.
That's 2.8.
What? Guys, not happy with that value. It's so different to the other one. 0.9563. Why do you... Do you know why it's basically the same? Simpson's rule uses what? Parabolic arcs in its approximation. And what's the sine curve looks like? Looks like parabolas. It's got the right sort of shape. You know how sine curve looks like concave down parabola, concave up parabola, sort of? Because Simpson's rule uses parabolic curves to approximate, even with less function values, you're getting a fairly accurate answer. All right?